I wanted to show a quick and easy way to check airflow. I got a new install here. I increased the filter size by making it diagonal rather than vertical. This is a 4-ton furnace with a 5-ton coil. That's what the AHRI matches up for 16 SEER. But I suspect the airflow is a little bit low because suctions was like 118 when it was pretty hot. The house was really hot. So I'm going to show you a quick and dirty way to check airflow without having to use much instruments. But you do need a very accurate manometer. So basically, this is Carrier, but all the brands have a table where you measure static pressure, and that's going to be return minus supply. So it's going to be after the filter and before the coil. So once you know static pressure, you go by your furnace size and speeds on high, and then you go look up and see what your airflow is. And it's reasonably accurate. It's more accurate for a new unit versus an old unit, because old units might have very dirty squirrel cage. So basically, you'll measure accurately what your pressures are. So I love using a little probe here, and that's just wrapped with Teflon tape, and I can probe, very small spaces. So actually I'm set on positive, so let's check our supply first. So I got a little hole right here. I check my supply. Now it does vary which way you have the air on it. So we're checking, you can also check it, inside the furnace, like where the safety is. So right there, 0.3. So I'll basically say 0.3 inches on the supply. And then I got to switch to return here. Flip my hose to the other port. So we're going to measure it after the filter. So 1/2 inch. Actually 0.4. So 0.5 plus 0.3. So we got about 0.8. So 1260, anywhere 0.7, 0.8. So we're about 1300 CFM on a 4-ton. So I am a little bit short of airflow on this unit. So I look at my speeds. Gray is the highest speed, and then blue is the second highest. And they were connected from the factory. Gray was cool, blue was heat, but I'm gonna put both of them just going to the gray. So either cool or heat is gonna turn on the gray, which is the high speed, and then I don't need the medium high speed. That's just capped off. So this will assure I'm running maximum airflow. Now I was able to add some airflow by cutting a hole there. I would normally just put chicken wire over that hole so it doesn't clog up, but this customer, they like to use double filtration, so I just basically put a filter box like so, and that's a quick and dirty way to add airflow. So that added about 100 CFM to the unit. And then when you go to the basement door, I got a little bit of air coming into the basement for negative pressure. You don't want to add too much or you can end up pressurizing the house and then having a lot of air infiltration. But that usually helps, because my bottleneck is the return, because I got 1/2 inch drop on the return, and then 0.2, 0.3 pressure rise on the supply, so bottleneck is there. But like I said, he likes running 2 filters. I'm not gonna change that, and the system will do fine now. Yes, my $400 Ashcroft gauge broke, cracked right on the bottom. So do I buy a new gauge? No. Fix it with a bunch of nylon ties. That screw's important on the top, because this is tapered. Should last longer. So now with the house cool, 108. So, and that's with the house 72 degrees at set point. So we're good. You go that low. I'm a little bit low on the airflow. The heat will be fine. The cooling is just going to dehumidify better, and the suction's fine. I hope you like watching the video. Thanks for watching.